Hello guys, in this video we will continue discussion about pre and boot application performance and schedule it. In previous two videos we covered quite a lot, pursuing some answers for our questions, and in this video we'll continue doing this and we'll cover even more. So let's jump to it. Yeah, for those of you who haven't watched the video, I will cover really fast what we have covered, but I still encourage you to go and check on the videos. So we were talking about schedule annotation. We discovered different scenarios of how to use it. We were talking about threads, executors. We discovered we talked about the way to run the task where a task depends on executor. Discovered the cases where things has to be run sequentially, not sequentially. We discussed how to monitor these threads, how to see what's going on inside. We talked about async annotation and how to use it. We were trying to answer the question, what the difference between scheduled parameters, fixed delay, and fixed rate. This is like kind of like our main topic, but we're not necessarily trying to answer this right away. We just go in the long way and exploring meanwhile everything that is related to the scheduler. We actually even covered in some other video, I will put a link below. We covered the so-called virtual threads, and we discussed if virtual threads could improve the performance of our applications and if we can use it for refactoring our existing application. So bear with me. Today we're gonna discuss something else, so stay tuned. Yeah, so far I will be sticking to what we just discovered and going from there. About async, about all this fixed delay, etc. So just taking into account what we discovered and take it as a truth. And the next thing is to figure out what kind of performance issues we might have knowing all this. What kind of best practices or bad practices one may use or find in the code, investigating whether your application has performance issues or not. So let's talk about it and see what we could find. Not best practices could be running like many threads like that, where you expected things to be sequential. So it's really depend on your scenario, on your domain where you're working on. Like in this case, we saw that these many threads happening when we use async or when we create new threads, right? You might want to create new threads. Be aware that this schedule and these new threads, they are not connected to each other. One giving rise to another and this live by itself. So the question is, do you really want this to work that way independently or not? Let's say this fetch is supposed to be doing something in 1 minute and changing the state of database. You don't want any other thread to be working with your database at this time because you're changing data, and let's say you don't use any locking or anything and you want to make sure that only you who is doing this, then you just, if you haven't completed yet with this task, okay, so this task will be naturally skipped, right? Because of this blocking and this fixed delay which is waiting. When you're looking for the code, it might be illogical to see a combination when we spin something in parallel. So that's to watch out. Another thing is, like I said, sometimes you might want to spin many processes like that. You might want to use a scheduler, some specific scheduler for your threads, whatever threads you use. And those threads will be work stealing threads and everything will be optimal, let's say. From one point of view, it's kind of nice to have work stealing threads because it's efficient to run stuff, but it's maybe not that easy to monitor it, right? Because if the work is still going between the threads, then it's not easy to track what's going on. But if you decide to go with many threads and you define a pool, let's say, and then the amount of threads will be limited, but it's kind of a drawback because it's the pool is limited and you may run out of this pool and then your application will fail. Another approach is to use virtual threads for your application. In this case, if we use virtual threads, then we may not care about how many threads are run. Like I said it before, we could be happy enough to see like many threads and we know that they are running without any limitations. So if you run out of your capacity of your machine, machine, well, too bad, but that's everything you have. But at least you don't limit yourself with some artificial pool size, because having this pool size, it's a problem by itself. It's like a fixed number of pool. There is no magic, automatically spinning pool or something like that. So the magic in this case is just not to put any pool size at all and use virtual threads, let's say, and hope that everything developed officially in JVM to handle all that stuff. Okay, let me do something here. So far, what we covered? We covered task scheduler. This is good. Task scheduler is responsible for scheduling task, not by running task, not by launching task. Okay, go in there and creating another bean and call it at pool task executor. Yeah, exactly. And then we will define the class itself. It's like that. Nothing fancy about it other than task executor. Set core. So let's say the core gonna be like amount of cores in the for the processor, for this specific processor. Set max pool size. Let's be 10 as well. And this is like a queue capacity. Name prefix. Well, because we want to see what's going on. Task executor. Let's see. Thread like that. We'll play with this one, right, later, and we will set this one. And then we will return basically that executor itself, and this way we can create it, right? Let's see how it works to run this fixed rate without async, right? So let's run it. So it's supposed to be running every 1 second, but there is 10 seconds. Scheduler is running here, right? That's what we printed. So we were expecting actually to see something like task executor, this one. How to do this? Well, it's easy. We have to inject word thread pool executor and call it executor like that. And now we want to run something in execute, and then we have to specify the runnable, basically something that is runnable. So my point is, you see, before we tried something manually with this thread, the problem is that the scheduler didn't know that this thread exists or and could somehow react on it. Could not wait or anything because it didn't know that the thread is existent. There is no reference. But in this case, we are actually creating the reference. So let's do it. So we execute. It wants to have runnable. Let's provide runnable. We can do it with lambda and do this. Sleep is okay. Sleep well. So what's gonna happen right now? Right now we're using this executor to execute some runnable, and this executor will be kind of connected to this scheduler, right? So let's test it. Oops, what's going on? Oh, interesting. Circular dependency. Okay, let's do something here. Let's create a class that we call pool configuration, and this class will be configuration, and we'll create yet another bean, and this bean will be named as same like that, and there will be something interesting. So public, here we will return thread pool executor, and that executor is actually will be responsible for executing our tasks. I'll explain you, but you probably already guessed what I mean, right? Because we're going by this path or figure out how properly to run our tasks so that all this framework with scheduled annotation would be aware about our tasks to be able to use properly this fixed delay and fixed rate. Exactly. By the way, we can move it from there to the configuration as well, so we can see it like the two of them. So first is this bean. We don't need to name it the scheduler, so it's responsible for scheduling the events, right? And this one is responsible for executing the tasks. So let's go and create some executor, and then we will test further. And everything's supposed to make sense. Otherwise it's not good. Set queue capacity. I need to do set queue capacity to, let's say, 5. We'll explain what it is later. Of course, we'll name it something like that. And then, but then we will go and experiment to see what all this means. Okay, so let's go back to our scheduler, and then, yeah, we'll do this auto wire executor this way. And then I already experimented with this a little bit. As you remember, before we had this code to be like that, blocking, right? We wanted to run this every 1 second, but we couldn't because we had to wait 10 seconds for easy. We just pass in here a runnable interface, lambda, and copy paste in our task that we used to have. That's how it works. And this is exactly the same code. So let me run this and see what's going on. So I'm expecting to have this task to be run every second because we're not waiting for anything, right? There is no delay for the task to complete. And each task will be executed, will take 10 seconds. Okay, in this case, what do we see? We see thread pool task 1, 2, 3, 4, 5. The way it's going, we got some delay, and then in 5 seconds we got another run. Then in 1 second we got another one, and again and again. I don't know why we had a delay between these two, but what you clearly see here that execution is going almost every second. What we see for sure that something has changed, right? The execution is working differently. First of all, it's not blocking anything right now, and it creates new threads every time, on like I would say arguably every second approximately, and it's not waiting for one task to be finished to run another one. So it's very similar to the same execution that we would had if we run everything in separate thread, right? So that's what we have. Let's go and check what it looks like in our visual VM. There is only one scheduled task, is this one. Then we're waiting for some time, and in 7 seconds it starts spinning. Why in 7 seconds? I don't know. Don't ask me. 6 seconds difference. But then you see start running. Okay. And this is our application. And that's what's going on right now. Thread pool task. You see we have like 10 of them. And why 10? Because this task takes 10 seconds to run, and we run it every second. So it's gonna be approximately 10 tasks always be present, right? If my math is correct. Nice behavior, actually. Easy to understand. Before jumping to conclusions, let's go and change something in there for this fixed delay. We want this fixed delay to work also for us properly, also with this executor. So let's wrap this with executor the same way we did before. The lambda. Mhm. Yeah, sure. This way. Now I'll turn off this scheduled and turn it on here. So what we're expecting right now, this is also taking, let's say, 10 seconds to execute this task. And this is 1 second to run, for the scheduler to run. Okay, let's run it. This is still supposed to be sequential, and it's supposed to be run every 10 seconds, not every second. No, it's actually running every second, so it doesn't care about our assumptions. It just works that way anyway. Okay, and we see there's several schedulers, 5 of them, and 10 tasks. That's fine. One doesn't wait for another one. So this fixed delay is useless because we use this executor. So in the way it's kind of not really connected. This executor doesn't connect to anything. But we will go and change something in the configuration. Okay, that configuration that we put here has something in there. For example, it has this set wait for task to complete on shutdown true. Because we have this pool, right? Pool of 10. Okay, let me just put it to 1 and run. So what do we have right now? We have only one task, which is expected 1, and we have failing threads 1. Yeah, it's something new. Why that? I have to remove this. Let's run it again. So what's going on right now? Right now we have one task, several schedulers busy, yeah, whatever. And then it actually waits for 10 seconds as expected because we use fixed delay. But so this works exactly the same as if we put everything into the body of this method without doing any executor or any runnable, same as blocking basically. The only thing is, I think they're still kind of connected because one is responsible for, the scheduler is responsible for calling this, but the executor is responsible for doing that. Right now, this executor is actually live separately in separate runnable. So technically we are not really blocking this call because we execute it in separate thread, but it behaves exactly as if we put it inside without any executor because, well, there is only one thread in the pool and it's not reusable, right? That's why we're having this every 10 seconds call, whereas one waits for another one because there is only one thread here. Okay, so that's my explanation for now. Let's do another test. This is fixed delay. We're going back to what we tested before, fixed rate. The fixed rate, if you remember, we were trying to figure out what the difference between fixed rate and fixed delay. This is not supposed to be waiting, but right now we use this executor, but executor has only one thread. So I guess this will not have any choice but to wait. So the result will be the same. Let's see. Yeah, the result is kind of the same. You see, this is 4084, so the next is 94, exactly. So 10 seconds, which is fine. So I think in general, this is the better way to do things with the executor, but we still can do this without executor. So that's a takeaway for now from this endeavor. Okay. Okay.